Okay.
Alright. Who has figured out something?
Oh.
Besides dirt, which I already gave you. Hopefully in a helpful way. Distance equals rate times time, the dirt formula. You guys never heard of that one.
Can we turn the 4 hours and 24 minutes into 4.4 and 4/10?
Maybe. Did you guys name the plane vector?
How is it 4.24? It's 24 over 60.
Well, kind of. And the wind?
You don't have 100 minutes in an hour. So
If it's flying into a headwind.
in 4:10.
If it's flying into a headwind.
So 44.
Huh. Is the plane and the wind working together or working against each other? And we don't have to stress about vectors because headwind means it is directly head on, right? Plane is going one direction, wind is pushing the other direction. So are we going to add the two and say they're working to make it faster or subtract the two?
Subtract the.
Less time on the way back though, right? Takes more time on the way there. So the plane is going slower. How much slower? Okay. P minus W is going to be the rate to, where are we going? Massachusetts? No, to Utah. The rate to Utah, you just erase the house, do UT instead. How about that? The rate to Utah is going to be P minus W. What's the rate going to be from Utah or to Mississippi? That's Missouri. What's Mississippi? MS? No, that's not. MI, isn't that Missouri?
No.
Oh, what's Michigan?
Michigan's MI.
Michigan's MI.
I think Massachusetts is just MA.
MA is Massachusetts. Oh, we're not going to Mississippi. Sorry, we're never going to Mississippi. What's Mississippi though?
MI?
No, I take that as anyways.
You guys failed geography. All right, so Massachusetts.
Wait, is this MA?
No, MA.
There are too many things to start with.
Wait, what?
Isn't MN Minnesota?
Yeah, Matt's Minnesota.
What's Montana?
No, MT.
Yeah. There's a lot of N. There's a lot of N ones. All right, let's just pretend like we know what we're talking about. Okay, focus back. So rate to Utah, P minus W. Rate to Massachusetts, P plus W. But we need distance equal to rate times time, right?
Yeah.
Okay. All right, guys, I'm competing way too much. For time, do we want to do hours and minutes, or just hours, or just minutes?
Just hours.
Just minutes.
Just minutes. All right, fine. So, how many minutes is 4 hours and 24 minutes?
Six times 4 is
264.
8 hours.
Not 284, 264. Good.
Dang it. Buckets.
Isn't it 4 times 60, which is 240 plus 24?
Yeah.
Okay. So we have 264 minutes, and then for 4 hours, we have 240 minutes, right? I feel like hours would have been easier, but that's all right. So now what do we do? Rate, Utah trip, Massachusetts trip. Rate, P minus W, times who? Rate times time, which is 264 minutes, is equal to 2,000 miles. Wait a minute, hold on. Do we want to know the rate in miles per minute or miles per hour? Do we want to know the rate in miles per minute or miles per hour? Maybe we should have gone with hours. It's okay, we can fix it. We'll do it in a second. And then we have rate times time equals the exact same distance, right guys? Luca, what's your question, Ben?
No, it's just, yeah, You can simplify that to 1.1 over 1. Or 4.4 over 4. 264 to the 240, just to make things easier.
Oh, are you dividing everything?
Yeah.
Yeah, we could divide everything. There are a few different ways of solving. Luca's saying, you know what, if you want to solve, you could go ahead and just make it a big old division problem, because with elimination yesterday, we saw not only can you add and subtract, you can also multiply and divide. You could try that. Although, you know what, I don't know if I want this guy to be divided, right? I don't know about that. There is another approach that's not wrong, and it will take a little bit of mathematical gymnastics to get there. Sean, what's another way?
I would distribute on the left side, and then since I would have the W's set on opposite signs. Oh no, wait. If I have that, then I can. Well, how would that help? Dang it. Oops.
You can divide both of them, and then solve for p substitution, and then plug into the other one. You can divide by 264, solve for p, and then plug in. Isn't there another way?
Could we set them equal to each other?
Yeah. How nice does that sound? Aren't the distances the same? So can't we just say, well, one has to equal the other, meaning 264. Do we want to distribute at the same time? Are we going for it?
Yeah, sure.
264p minus 264w is equal to 240p plus 240w. Wait, now what do we do?
Let's get stuff to same sides. Separate.
We could.
Isolate a variable?
We could subtract 240 from 264, I suppose. And that would be 24p. If we move that guy over. We can move the other guy over, and we would get
504.
Well, what if we like divided by 24 and then we got
You
like
got 21.
a kind of like a constant, so we could plug it
okay,
back
we
in.
could do that. So then maybe this isn't the end, but maybe this is one means to the end. So if we divide everything by 24,
You get 21.
okay,
21W, so then we can plug that back in as P.
where do you want to plug them? You can't plug them in here or here, because if we do, they'll just cancel out. Remember, we have to back substitute into somebody else. So we can go to either of the ones up top. Which one do you want?
You're already hooking left.
Okay, we're going? All right, we're going. So we can plug in there. We can say, all right, fine. P equals 21W. So we can say 21W plus W, which would be 22W times 240, right? Equals 2,000. We get 22W. What's 2,000 divided by 240? Or if you just want to solve all the way, what does W equal? 2,000 divided by 240 divided by 22. Can you go ahead and go math fraction for me, Luke? What's that fraction look like? What is this measured in? Miles per minute. Huh. No wonder it's small. You're not going to go very many miles in a minute, right? Okay, so hold on. How do we convert this to make it something that we're used to?
60 minutes in an hour.
60 minutes in an hour. So maybe we should have stayed in hours. I just kept it in minutes because that's what you guys thought of, and I showed you it's possible. Multiply that by 60, and what do we get? 250?
You got 15,000.
Whoa.
No, I'm
25.
getting that 250 over 11.
1,500.
So that's 22.
1,500 over 66.
Oh,
No, sweetheart.
That's pretty funny. 25 times 60.
0.
That's about right, but then divide it, what do we get?
Then divide it.
22.7.
Good. 22 point what?
6.
.727.
All right, and that's in miles per hour. That doesn't sound too crazy. That's kind of a reasonable wind speed, right? But wait a minute, what else do we need? Oh, come on, guys. We found one variable. We need the plane, right? So let's go back and plug it in. And don't we have an equation just waiting to be plugged into?
Yes.
Okay. Are we going to plug in the 22.727 or the 25/66? Are we going to plug in the 25/66 because that's what the units are in, then we're going to multiply by 60 for our minutes per hour to go ahead and make it all work out? So what is 21 times 25 times 60 all divided by 66? Remember, even though you did get miles per hour for wind, the whole problem was in terms of minutes per hour, so we have to plug back in that original 25/66. Then convert, hence why I have the times 60 minutes per hour. And what do you guys get? Hopefully it's a lot faster than the wind.
477.272.
Anybody back them up?
Yep.
Question. Did this need a system? Yep. How do we know? Because there were two different legs to the journey with their own pieces of information, right? And then how many different variables did we have? 2. So we had to use a system in order to be able to solve. Now, was there kind of a physical sciencey sort of formula we were supposed to remember? Yes. But besides that, it was a plug and chug. The one thing that might have made it easier is if we had not gone to minutes. I bet that would have been a little easier. All right, cool kids. With that, we are done with section 7.2. Homework on 7.2 is due tomorrow. But what else does our board say our goal is today?
Start 7.3.
Ooh, we have X's and Y's and Z's. We have X's and Y's and Z's. Getting there. Chapter 7 does get to matrices.
The second one's nice.
The second one's way nice, right?
Yep.
I agree. Do we fully get to matrices? Nope, we'll fully get to matrices in chapter 8, but we are introducing some matrix math ideas. Just so that it's out there, yes, what you see in front of you could be solved with matrices. I agree. And yes, your Algebra 2 teacher might have taught you how to use your calculator for matrices. I agree. But remember, this class is pre-college math, and not like Algebra 1, like make them believe that you at least kind of get math enough to let them go be an English, or for them to let you go be an English major or something. I'm talking college math like the beyond. The Calc 1, 2, 3, linear algebra, differential equations, etc. Linear algebra, what is that?
I don't know, but it's
Has to do with this stuff. Has to do with matrices. And college professors don't like calculators.
Oh.
Nicole, what's that?
how many sections?
I think 5. Let me check. No, more than 5. 4, 5, 6, 6. 6 sections.
Halfway.
So I'm getting you ready for linear algebra. If you want to do anything computer science, anything engineering, anything physics or math, you would need linear algebra. Nice thing is, last I checked, medical does not need linear algebra. Luca, what's up?
What's the level of math you need to go for like
Med
business school
Oh, business school?
or like economics?
Economics, you probably need more math. You need lots of calculus because it's a very useful thing in economics these days.
Mm-hmm.
In the last like 30 years. For other business calculus and statistics is probably enough. Business calculus is kind of like calculus 1, put together with lots of business ideas. If that makes sense.
Mhm.
And statistics is its own little thing.
I noticed a whole lot of graphing and
A lot of words, a lot of graphing, a lot of memorizing, but not bad. So math is not as fun for me, but it's more fun for other people. Hey guys, which one do you like better, the left one or the right one?
the right one.
Why?
Because you already have one given.
She's so nice.
You have Z given.
And what can you do with z?
Plug them in.
Go back. And what can you do once you solve for y?
Go back.
You go back another one.
Go back and plug in for him and him and find x.
That looks gorgeous.
This is called, even though it has x's and y's and z's, it's called something that you might have seen with matrices. Row echelon form. A stair-step pattern with leading coefficients of 1. Do you see the stair-step? Kind of like upside down, but it still works. It's a stair-step pattern with leading coefficients of 1, and it is so much nicer to solve. Now here's the crazy thing. What if I tell you that this is equivalent to that?
I honestly don't know these things.
How do you guys notice? What would have given you a clue that they're equivalent?
The first one has the same.
Oh, they both have the same first equation. Now question, do you guys know the math to take the yucky one and get it to be the nice one? What's the math to take the yucky one and get it to be the nice one? What if you use the first two and eliminate the x's? What would negative 2 plus 3y give you? What would 3z plus 0 give you? And what would 9 minus 4 give you? Oh, maybe it's not too hard. How would you get the third equation? Any ideas? Could we maybe get rid of the x's in this one too? Now we'd have to do some math to do that, right? We have to multiply the top by 2. But couldn't we get to a point where we get rid of the x's? And then we just have y's and just have z's and we already have y's and z's? We're going to talk about that in just a little bit. This is called row echelon form, and as we all unanimously probably said, this one's better. But the dilemma is how you go from the yucky to the nice. You guys ready? Second. Long story short, we need to make sure the systems stay equivalent. If they don't stay equivalent, if we make an illegal math move, then we've just messed up the whole thing, right? So we need to make sure the systems stay equivalent. We can do that by what is called for matrices row operations, but it kind of applies for equations, systems of equations as well. Snazzy, snazzy, snazzy term for it. Gaussian elimination. All from the mathematician, is it Friedrich Gauss? I should know that. The Gaussian elimination. Legal math options for keeping the systems equivalent. And here they are, 1, 2, or 3. You can switch up two equations. Put the top one second, put the second one first. You can switch them up, put them in different places. You can multiply entire equations by a constant like we did with elimination. And you can add together. So basically, you can interchange and you can, oh no. He died. Hold on. He didn't literally die, he just went away. Had to happen at some point this morning. I know. Take a breather. Ask kiddos in your group. What should we ask them?
What do you want to do it now? Do it.
How their week has been. How their week has been. You guys talk into your group. Ask them how they're doing. Ask how their week's been. Worst comes to worst, ask how the rain's been. Maybe they like it, maybe they don't.
It's in that little chair.
How's your car?
Why?
Okay, so each chapter. What was the last grade?
So mystery.
Review of chapter
Okay, so you got no chapter 5
I
in.
said first you said it would
Correct.
No.
Look in the very back.
Wait, I know, but you took, did you take off the screen? And that's
Okay, more fun than
and I like
Start with section 5.3. 5.3, 5.4. Okay, you can go to my website. It's bookmark and Google Chrome. Go to honors.
A month?
Class folder.
You don't have.
Alright, you guys got it? It's done.
Wait, did you?
It's a chain game. We gotta do it link by link, or else we won't get to our stair step. Step by step. What? Stair by stair. Hey. Isn't there a new song for chair by chair?
Chair by chair, we get cause we can.
Really?
Alright, you guys got it? Chain game. Get the stair step. We like that stair-steppy thing. We want that stair-steppy thing. It makes our life so much easier, but we gotta follow legal steps to get there. And I call it links. Well, we'll see why in a second.
Yeah, I'm just confused because there was never a chapter 5. Was that last semester?
That's what I had to think through.
Because he doesn't have a grade for that either.
Alright, how about now? Okay, so I'm gonna highlight a couple things. First, we can interchange if we need to. Second, we basically just do elimination. First, we can interchange if it's helpful. Otherwise, we're basically doing elimination. If I can spell it, I'm just gonna do it. Elim. How about that? There you go. We're basically doing elimination, but we're doing elimination with. Ready for it? X terms in one pair actually let's change that. X terms in two pairs of equations. X terms in two pairs of equations. And then Y terms in remaining pair. They're ultimately, no, you just started working. There are ultimately 3 links to this process. Let me see if it comes. Yay, there he is. Ultimately, there are 3 links to this process. As long as we have 3 variables. If there were 4 variables, there'd be 4 links, etc., etc., etc. But for 3 variables, 3 links, let's go ahead and see how it works with this example. Solve, but don't solve until you make the nice stair step. Zoom in. Zoom in. There it is. Huh? Yeah, ultimately, now I'm not going to show all of this right away. But let's do it with a star. How about that? Okay? The number first one He's a keeper. I'm going to mark the keepers with stars, but let's not do anything with them yet. He's a keeper. However, I have to make the first link, and the first link is, you ready? The first two. You gotta take the first two. So let's go ahead and take the first two off to the side. We're gonna have x minus 2y plus 3z equals 9. And then negative x plus 3y equals negative 4. And what am I doing to the first two since they're all nice and just waiting for it?
Oh, I got it.
Eliminate, right? Okay. So what do we get?
Y plus 3z equals 9.
Guess what? He's also a keeper. I need an equation with an x, y, z, or at least an x. I need an equation with starting a y, but now I need an equation with starting with z. Yeah. Let's see how it works. Next link.
Oh my goodness, wow.
Take the next two, although he's a bit bigger. That's kind of awkward. Hold on, let's try again. Okay, so take the first two, then take the next two. Now let's rewrite those. So we have negative x plus 3y equals negative 4. 2x minus 5y plus 5z equals 17. Now, why don't we just say, let's go? Or is that a bad idea? Yeah, so what do we do to the whole top one? Because we want to get rid of the x's. But if we multiply that by 2, who else do we have to multiply by 2? Everybody, right? So, let's multiply all of this guy by 2. So we have negative 2x plus 6y equals, let's go. So we're doing the first step of eliminate x's in two pairs. We end up with y plus 5z equals 17. If you guys look at your notes, if you guys look at your notes, remember I said eliminate x's in the first two pairs and then eliminate z in the resulting pair. In the resulting pair. So let's go ahead and take these two. Let's set them up and say, all right, we got y plus 3z equals 5. We got y plus 5z equals 9, but why am I not filling in any of my signs? Because I really want to multiply all of them by negative 1 to avoid silly math mistakes and killing poor little seals by not distributing my negatives. Now I can add down, what do I get? Negative 2z equals negative 4, but I can, of course, then say z equals 2. Guess who he is? My third keeper.
Oh my goodness.
So what am I going to take with those three? Set up my equivalent system that says take the three keepers
And you set them up.
and set them up to solve. There's my stair step. You guys got it? Now, if you guys want to go look at the original examples, is this the way to make him into him? You notice they were the exact same two?
Yeah.
So how do we go from one to the other? We follow the system, link by link. Take the first two, take the second two, eliminate the x's in both. Take the remaining two, eliminate the y's. Take the keepers, and solve, solve, solve. So let's solve, solve, solve. We didn't finish before. We know that z equals 2. That's all well and good. But who else do we know? Go backwards. Y times, or plus, 3 times 2 equals 5. What does y equal? Y plus 6 equals 5?
Y plus negative 1 and 1.
Doesn't just equal negative 1? Plug in 2. 3 times 2 is 6 and subtract. Is that all right? How do we find x? We just keep on plugging and chugging, right? Yeah, so x is equal to negative. Some of you are doing good mental math, which is good. Just make sure you don't make any mistakes with it, yeah?
Dangerous.
10 minus, I guess I'm having too much fun. It's 2 times negative 1, but just in case some of you guys aren't tracking. 2 times negative 1 plus 3 times 2 minus 9, sorry, equals 9. That'd be plus 2 plus 6, 8, x equals 1. How do we write a 3-dimensional coordinate?
Like the normal one. X, Y, Z.
3D.
X,
X,
Y, Z. Dun, 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 dun.
What's the graph?
Should we graph it? There's the X, there's the Y.
Oh my gosh, I remember this is like the.
So you can go over one, and you can go down one, and then you can go out.
Yeah, when he did it in the room.
Get up and do it.
The approximate you're there. Chase is dead. I love that one every year. It was memorable. I don't know if you love that. The kids always love it.
Oh.
Whoa! Mind blown! 3 dimensions! What's going on?
It's actually really cool. It's really cool.
Do you want us to draw that?
If you want to. Or you can just write the words. Okay. We already talked about consistent, inconsistent with x and y's only, right?
Yes.
Consistent and inconsistent with x and y's only. Or with x and y's only, consistent could look like this, with 1 point. Or consistent could look like this, infinitely many points. And inconsistent looks like that, right? But as soon as we go to the 3rd dimension, life gets a little more exciting because we could just get one single solution because all 3 planes only intersect all together one place. We could get an entire line of solutions because all 3 planes intersect in planes, x, y, z's. All 3 planes intersect in one line, which is still infinitely many, but restricted. Still infinitely many, but restricted. Or we could have a plane where it's literally, they're all on top of each other, and so all solutions, infinitely many, non-restricted. It's all. Inconsistent could happen 2 different ways. Inconsistent could happen that absolutely none of them intersect at all. They are all parallel. But the other way is that one plane intersects with another, and the other intersects but at totally different places. There's like an empty spot inside. And so all 3 do not intersect anywhere. Now, the nice thing is, either way, the math isn't going to work and we're going to get a false statement to say none. But there are different ways of being inconsistent. There are different ways of being inconsistent. Now, you guys don't necessarily have to draw the pictures. My artistic ones, you might have fun trying to get the dimensions. Yeah, they're interesting. You can kind of think about this if we were to take like some plain deck cards and if we were to slice them up and put them together, this kind of makes sense, right? They can all intersect in the line. They can not intersect at all. They can be parallel. Have a little teepee with like a little empty space in between where that's all like hollow, so none of them meet all together. But anyway, I just want to let you know that the exact same classifications still exist. They just look a little differently in the 3rd dimension. Look at.
What do you consider the one line restricted and the other one plain?
Because the one line, there are infinitely many. Both of these technically are infinitely many.
Mm-hmm.
However, this one, there's going to be some sort of restriction. For example, instead of y equaling a number at the end, we're going to get, for instance, y equals 3x. So, for instance, let's see, how can I explain this? Not 3x, let's do 3. What's the variable I use? Is it n? Hold on, where's my n? set of equals. I think it's n. Sorry, I don't remember the variable I usually use. But if I was to say something like 3n, and n is within all the counting numbers, so 0, 1, 2, 3, etc. Y can equal any whole power of 3 or any whole multiple of 3, but it can't equal every single number, if that makes sense. So they're restricted in that it's infinitely many, but only on this line, whereas this one is infinitely many for the entire space. Does that make sense?
Yeah.
So they're both infinitely many, but in very different ways. Long story short, this one is a lot stronger because it's a lot greater. So it includes a lot more points. This would be an example if you got something like 0 equals 0. And you would say something like, yes. But that would have to be true for all 3 systems. Alright, let's go check out one last example. Oh my goodness, we're like almost to section 7.3a, which means tomorrow we'll get to finish 7.3a. Oh, where's my system? I don't know. He somehow got covered up when I tried to save him. It's okay, let's go find one. We might not be able to finish solving the entire guide today, but we can go find a guide for tomorrow. At the same time, you guys can go ahead and see what the section's going to look like. If you guys want, I think I still have your homework sheets up. Oh, I don't. That's all right. You can go there quickly. You guys want to write down homework for section 7.3a? Yeah. Fine. They're all over. No, 7.2 is his own assignment, and 7.3 has his own assignment. The computer's taking a long time. So if you haven't done 7.2 yet, then you might not want to write down 7.3 yet, unless someone has fully attempted 7.2 and wants to say how many pages they use.
It's a front and back.
Front and back? Okay. If you guys want to skip about front and back. Coming. Come on, homework sheet. Come to life. Furious. Ay. Computer.
Oh, okay, so we have 2 assignments for 7.3.
Yeah, for 7.3, there's going to be an A assignment and a B assignment, just because they're different.
But the
If you notice they're not super long, I just wanted to kind of make sure you guys,
understand.
do it piece by piece and don't necessarily try to do it all together. Sorry,
Is
the
7
computer is not happy.
Is 7A going to be due on Thursday?
Yes. And it might be 7.3a and B, depending on how well we do tomorrow. Remember, if we can, we would love to not have that test after President's Day, the day after President's Day. So if we can get through enough, then we'll have 7.3a and B maybe do it at the same time. But if we can't, then we'll just use 2 separate days. Lunch would be better. Can we do lunch? Let's do lunch.
So,